Welcome to The Explainer. So, how do you count something you can't even see? And I don't mean just a few things. I'm talking trillions upon trillions of them. Well, today we're going to pull back the curtain on the ingenious tool chemists invented to do exactly that. A concept that really is the foundation for all of modern chemistry.
And here it is, 602 sextillion, 300 quintillion. It's a number so outrageously huge that our brains can't really even process it. And yet, this isn't just some abstract number from a math class. It's one of the most important values in all of science.
To even try and get a feel for a number that big, let's use an analogy. Let's forget about atoms for just a second and picture something we all know, a simple grain of rice. What would it look like if you had this many of them?
I'm talking every single continent, every island, every little bit of dry land on our planet would be buried under a blanket of rice as high as a 25-story building. Just think about that for a second. That's the mind-bending scale we are talking about here.
So this gigantic number actually has a name, Avogadro's number. It's named in honor of an Italian scientist, Amedeo Avogadro, whose early work really paved the way for this whole idea. It's a specific quantity of particles. Could be atoms, could be molecules, you name it. It's basically the universe's counting number for all the super tiny stuff.
And you know what's crazy? It doesn't even matter what you're counting. The number is always just staggering. If we swapped out those tiny rice grains for something bigger, like marbles, a mole of them would cover the entire planet 3 miles deep. Yeah, this number is just on a whole other level.
Okay, so why on earth would scientists need a number this absurdly big? The answer gets right to the heart of a huge challenge in chemistry. Think about it. Even the tiniest little speck of dust you can see has trillions and trillions of atoms in it. You can't possibly count them one by one. I mean, even a supercomputer counting 10 million atoms a second would take something like 2 billion years to finish the job. So yeah, chemists really needed a shortcut.
And that's where this brilliant idea comes in, a special unit called the mole. And really, you should think of it just like any other word we use for a specific number.
I mean, we do this all the time, right? You say a dozen, you mean 12 eggs. You say a ream, you mean 500 sheets of paper. Well, for a chemist, mole just means they have that big old number of particles. It's kind of like the chemist's dozen. Okay, so the official textbook definition is pretty straightforward. 1 mole, you'll see it written as MOL, is just the amount of anything that has Avogadro's number of particles. But here's the real magic. Its true genius is how it connects the tiny world we can't see with the world we can actually measure in a lab.
And that brings us to the mole's absolute killer feature. This is where it goes from just being some huge number to being an incredibly useful practical tool. It creates a bridge, a direct link between counting invisible particles and just weighing something on a scale.
Okay, so here's the most brilliant part of the whole thing. Scientists were super clever when they defined the mole. They set it up so that the mass of one single atom measured in this teeny tiny unit called an atomic mass unit, or AMU, is the exact same number as the mass of 1 mole of those atoms, but measured in grams. That's the key.
All right, look at carbon. A single carbon atom weighs about 12 AMU. And thanks to the mole, we know that 1 mole of carbon atoms weighs, you guessed it, 12 grams. Same with water. 1 molecule is 18 AMU, a whole mole of water is 18 grams. It's this beautiful simple trick that lets chemists count atoms just by weighing them. It's amazing.
So what's the big deal? What does all this actually mean in the real world? Well, it's the thing that turns chemistry from just a bunch of ideas on paper into something you can actually do.
Because of the mole, chemists can finally connect the dots. They can count out a bajillion atoms just by weighing a powder. They can take a formula from a textbook and turn it into a real-life experiment. It lets them write and balance their chemical recipes, their equations, with total precision. Honestly, without the mole, modern chemistry, making medicines, creating new materials, none of it would be possible.
So you see, the mole isn't just a number. It's a really clever idea. It's a perfect example of how we can come up with an elegant solution to a problem that seems totally impossible. And it kind of makes you wonder, right? What other amazing shortcuts are just hiding out there in science, waiting for us to find them?